Welcome. This is another technical technician video brought to you from Diagnation. And the title of this video is going to be called the Mortal Coil. And we're going to strictly talk about ignition coils on cop or coil on plug setups. We're not talking about distributors or waste sparks, although the principle is quite similar. We want to talk about the really vital signals to make a coil produce a spark. And in most cases, of course, a coil has to have power, a coil has to have ground, and a coil has to be triggered. On the Hondas, the Nissans, and some other manufacturers, we use a 3-wire coil, and one wire is a power, one wire is a ground, and one wire is a command or a triggered input from a PCM. Usually it's a PCM, and that determines when the spark is supposed to happen. Other coils, we call them, I think they use the term dumb coil, kind of Ford, Chrysler, some Hyundais, where it's just a 2-wire coil. And the PCM itself is the component that triggers the coil directly. It's hardwired. The current flowing through the primary side of the coil will actually flow through the PCM, not in this case. Obviously, as you look at the schematic, take a screenshot of this. We're going to get to the scope real soon. We have power from the coil relay, we have a ground, and we have a trigger from the PCM. We're strictly going to be dealing with coil number 4 for this setup, although it does obviously have 3 other coils that are fed the same components, power, ground, and control. Of our scope, we're using the MIG-SIG. Channel 1 yellow is the feed to the coil right there. Channel 2 blue is the ground on the coil. Channel 3 is the current ramp of the coil, strictly the number 4 coil, and channel 4 is the trigger signal from the PCM. Let's just get over to the scope and I'll set the scope. We'll kind of analyze the signal. We have the scope rolling, and remember, we're going to be about 200 milliseconds per division. I will start the car, and then I'll kind of play. Let's just talk about settings for a second. I know my first setting, yellow, is I need that in a 0 to 20 volt range. So that's on about 5 volts per division. My blue channel is the ground of the coil, so I can use less for better granularity to look at the ground of the coil, which is, they're all important. And I'm at 1 volt per division. The purple channel is the current clamp, which the attenuation factor is 10 millivolts per amp. That would be 10 millivolts per 1,000 milliamps. So I'm at 200 millivolts per division. Most coils are in the 6 to 8 amp range usually. And channel 4 is the triggered signal from the PCM. That is a 0 to 5 volt trigger. I'm at 2 volts per division. I will start the car, get a long capture, and we'll let it go. And I'm going to actually let me shut the heater off, air conditioning. I'll go to a longer time base. Here is my time base adjustment at 500 milliseconds. And I'm going across the screen. And I will give it, we're basically going to stop the capture and kind of analyze. And we'll talk about each component and a little bit about coil diagnostics and things you want to be careful of when you're diagnosing a misfire and you have belief that it is an ignition-related misfire on a specific cylinder. So let me get my trigger over to the left so we get a full screen on here, right there. And then we're gonna we're gonna stop the capture pretty soon. Okay, did we stop it? No, not in time, gotta keep going. All right, this happens once in a while. Okay. No, I did not get it. Okay. This is what happens sometimes. We're shooting live. Got it. Okay, this does happen every now and then with this type of scope. It's a good scope. It doesn't have the buffering capability of a Pico or an E-Scan or other scopes, Snap-on. But now we have a capture, and we're going to shut the car off. We'll kind of talk about it. I'm going to zoom in on the time base. It has a feature where you can actually roll this. I'm just going to kind of do it this way. Go the other way. I want to go to kind of zoom in on everything. I'll go to 50 milliseconds, and we can see quite a bit there. even more, and I'll bring this down. Yellow is channel 1. That is our feed to the coil. That is strong. That is about, looks like about charging voltage. I will check everything with cursors. Let me get the key out of there. We can see we're strong here. We're strong here up on yellow. That tells us we have full voltage to the coil. We're low on blue, which is good. This is low. We got a little bit of more voltage drop right when the event happens, right when the current flows. Obviously, there's voltage drop. That's a good sign, and it's all synced to the coil in purple. That's the coil. Let me roll this over. Yeah, now we got a little more stretch here, and now we can see a good pattern. I just wanted to kind of analyze this, and we have a nice ramp. We never want to go straight up on a coil. That would imply we're shorted. We got a good ramp. We got a good peak amperage here, and we got a good trigger from the PCM. The PCM trigger should usually clip. Well, let's. What I'll do is I'll get the cursors out, and I'll measure the just the green channel. I'll swing the cursors up like this. We want this. We want channel green right here, and we got about how many volts on that? We're looking about, I guess, 4.44 volts. That's good. That's a good amount of voltage. Usually runs between the 4.5 to 5 volt range from the PCM. You never want to see it ballistic way go too high, and you never want to see it very weak and low. That's an issue. But this is a good looking coil, and we can see we have all the signals to produce a spark. Nonetheless, we still have to consider secondary when we have a coil under suspicion. The secondary part of the coil where the voltage is jacked up from the primary to produce a high voltage spark, and that's real important. What I learned about coils that are bad, from a bad secondary, you see where I'm running this mouse, and you don't see it on this scope. Sometimes when you see excessive hash going down on purple, that's an indication of a secondary issue. So if the coil is not producing proper spark, that's something to be mindful of when we got coils under suspicion and we're troubleshooting them. But as far as this pattern, we're good here. We're strong on the feed. We got a good ground. We got good ramp. We got good current flowing, and we got a good trigger. So just be mindful of that when we're troubleshooting coils. And all these things have to be good for the coil to produce a spark. Anyway, thank you very much for watching.